This is just a quick reminder video of how logarithms work in case you have an integration or an antiderivative problem where you end up with the log of some base and numbers in there as opposed to just variables. Often they simplify to a specific number, and you would be expected to know how to do that. So let's just review just that aspect of logarithms really quickly. Now, to get to that part, remember that where it starts is it started with exponents, and you had a base raised to some power, and you would get a result of some type. It's sort of like if you had 4 squared equals 16, and then you learned how to talk about logarithms, which are the inverses of exponents, right? That like multiplying and dividing reverse each other, adding and subtracting reverse each other. So what you would have is you would change it to the log format, and you would have the log, and then down here in this little tiny number in the basement, you would have the base of the result equals some power. Logarithms are just magnificent for finding powers. You know, there's a lot of things you need to know about the power is or how it turns out to be, and so they're just tremendously helpful. So if you were going to change 4 squared equals 16 to log form, you would say log base 4 of 16 is equal to 2. And once you get used to this, right, and you can kind of interpret the logarithm as an exponent, then what happens is you would say this is your base, this is your power, this is your result. So 4 squared is 16. Now, the trick is, I guess, to get comfortable enough with it so that you can read it without the equals. Okay. So if you end up with something and it says log base 3 of 9, and that looks like, man, I wonder if that cleans up or simplifies to some nice number that my teachers expected me to know what it is. So you can think of it as log base 3 of 9 is equal to some power, and go through this process and go 3 raised to some power equals 9. Or you could try to get strong enough and mentally with this concept that you can kind of do it in your head. So you're basically saying, if this is a little question mark, make it look more like that. 3 to what power equals 9? That's what you're asking. Well, 3, okay, what would the power have to be? It would have to be 2. So this is equal to a 2, right? So log base 2 of 16 we're saying that looks like that might be equal to a number. So what you're asking is 2 to some power equals 16. So what would you have to raise to 2 to get 16? Well, the power would have to be 4, right? So that reduces down to a 4. So log base 4 of 1 over 64. What you're saying is 4 raised to some power equals 1 over 64. Well, you flipped the 4 down, so it's probably got a negative sign in it, and then you cubed it. So this turns out to be a negative 3 because 4 to the negative 3 is 1 over 4 cubed, which is 1 over 64. Okay, you kind of catching on? So then they say, okay, what's log base 6 of 1? 1. So 6 to some power equals 1. Well, 1 to 1 is 1 to the first power is 1. Everything else is itself or larger, right? 2 to the first is 2. 2 squared is 4. You can't get back to the 1 unless you remember the rule that says anything to the 0 power is 1, right? So what does the power have to be to get 1 from 6? It has to be equal to 0. So then they had the natural log. Now remember, the natural log is actually log base e. It's just shorthand for log base e. So there's an understood base of e down here. So you're saying e to what power equals e squared, so the power has to be 2. Okay, what's the natural log of 1? E to what power is equal to 1? Again, that would have to be equal to 0. So what you can kind of put into your mind as a rule to keep up with is if you have any log, okay, any log of any base e, base 4, base 5/7, okay, whatever, any base, and you get 1, the power has to be 0. Okay, so I hope that helps you kind of remember how logarithms of numerical values work, so that if you do end up something when you integrate and then substitute in for these C's and D's or C1, C2s that you're solving for, then you can clean them up and simplify them just a little bit. Okay, and recognize them first and then clean them up. And that's the end of the review.